What causes bad results in supervised learning models? Imagine trying to teach a friend to recognize different fruits. If you give them wrong clues or confusing pictures, they might get it all wrong. That's similar to what happens in supervised learning models when things go wrong. Supervised learning models learn from labeled data, which means each example has the correct answer attached. If this data is messy, incomplete, or has mistakes, the model can get confused. For example, if a dataset about emails has labels that say spam when they are not, the model will learn the wrong patterns. This leads to poor accuracy when it tries to predict new emails. Another common problem is missing important causes. Models often find patterns based on correlations in the data. But sometimes these correlations are not true causes. If the data misses key factors that really influence the outcome, the model might make predictions that look good in training but fail in real life. For instance, a model predicting health risks might rely on age and weight but ignore lifestyle factors. If the data only shows a correlation between these and health issues, the model might give misleading advice. Overfitting and underfitting are also big issues. Overfitting happens when the model learns the training data too well, including noise and outliers. It becomes very specific to that data and struggles with new, unseen data. Underfitting occurs when the model is too simple and cannot capture the real patterns. Both problems cause the model to perform badly when used outside the training environment. Data distribution changes over time can cause problems too. If the data the model was trained on is different from the data it sees in real use, the predictions can become inaccurate. This is called data drift or distributional shift. For example, a weather prediction model trained on data from one region might not work well in another if the climate differs. Differences between training and deployment processes can also cause issues. If the way data is prepared during training is different from how it is processed during use, the model might get inputs it was not trained to handle. This mismatch can lead to errors and poor results. Testing is another key factor. If a model is not tested on a variety of realistic scenarios, it might perform well in testing but fail in actual use. Proper testing should include different types of data and conditions to catch potential problems early. Lastly, ethical and societal issues can cause bad results. If the training data contains biases, the model might produce biased or unfair outputs. For example, AI tools that generate images or text should be monitored to prevent harmful stereotypes or misinformation. In all these cases, the main causes of poor results are related to data quality, model design, and how the model is used in real life. Ensuring good data, testing thoroughly, and considering ethical factors can help build better supervised learning models that give reliable results.